Yes, here we go.
Hold on.
I didn't know it was gym class, so it's not.
All right, Peyton.
I'm sorry.
Okay, does everybody have a note sheet?
How do I enter it?
Click out of the text box. Just click on the background picture and it'll post. Okay, so properties of water. All right, we are starting a new unit today. The big unit name is called Solutions. Okay, and it's about how to make a solution, what causes a solution to dissolve, things like that. But what we got to do first is cover some background information, and that is properties of water. Okay, that's what today is going to talk about. We will do a little bit of a lab the next few days to look at these different properties, but today is just note version of these properties. Okay, so the way that these notes are set up is each section is a different property of water. Okay, and we're going to talk about them. There's 8 of them. Some of them kind of go with each other, and I'll let you know which ones go with each other and all of that. Okay, after we do this, we're going to do our 5.1 assignment in Canvas. Today's going to be a pretty short day if y'all bear with me. What's up, Brooke? Yes. Merry Christmas. Okay, the first property that I want to talk about is universal solvent. Does anybody know what that means?
No.
Wait,
What does universal solvent mean? What do you think it means?
Like our galaxy.
I will tell you what it means. Okay? So if something is a solvent, that means it can dissolve something. So water is a solvent because it can dissolve sugar. It can dissolve salt. Okay? If it's a universal solvent, that means that it's used a ton by everyone to dissolve something. Okay? So that's the first property of water, is that it is a universal solvent. Water dissolves a lot of other substances. Example that we're going to write down is NaCl, which is salt. Okay? So that first property is telling us that water can dissolve a lot of different substances. Okay, our next property of water, the polar molecule, goes hand in hand with this universal solvent. Okay? So basically, water is a universal solvent because it's a polar molecule. And all that it means to be polar is that there's a positive end and a negative end. Okay? Raphael, focus. Water molecules have a slight positive charge on the hydrogen side and a slight negative charge on the oxygen side. Okay? So that's what makes it polar. There's a positive end and a negative end. And because it's polar, it can dissolve a lot of different substances. So, this is my water molecule. What is going to go in these positive circles?
Hydrogen.
Hydrogen. So, 2 H's. The negative is oxygen. Okay? So, water is polar, and that helps it dissolve a lot of different molecules. Okay. This next property I want to talk about is cohesive. All right? So, water is cohesive. Let's talk about what CO, that prefix, can stand for, okay, or what it means. So, if you think about me and Linda runs her business, I run my business, okay, and we're trying to do the same thing, so we become a cooperative. My business and Linda's business, we want to reach the same goal, so we decide to join forces, and now we're a cooperative. So, me and Linda are going to work together as a team, as a cooperative. Okay, does that make sense? Have y'all heard that cooperative word before? Right? So that prefix co means together. So like me and Linda would be working together. It can also mean common. Me and Linda's, our businesses are common. They're very similar, and we join forces. Okay, so we're now a cooperative. So now what that means in terms of water and cohesion is it's going to be water sticking to water. So a common substance sticking to another common substance, which is water. Okay? So water molecules are attracted to or stick to other water molecules. So cohesion is water sticking to water. That's what you need to know. Water sticking to water. Okay, whenever you have a drop of water, does it like splatter or does it stay in a bubble? It stays in that bubble, okay? That's why it's called a raindrop, a water droplet. They stay in that bubble. They stay in this shape like this because they are cohesive. Those water molecules want to stay together, so instead of spreading out, they stay in that one single water droplet. Okay, this cohesive property of water, water sticking to water, also works with this next property, surface tension. Okay, so cohesive and surface tension are going to go hand in hand. So, let's talk about surface tension. You have experienced it already, you just may not have known what it's called. Okay, so have you ever you were at the city pool, you were doing a trick on the diving board, and you messed up and you like belly busted or you busted on your back and it felt like the water slapped you. You ever felt that? Okay, that's because water has surface tension. Okay, that slap that it feels like is that top layer of water and that surface tension. So, what scientifically is happening is the top layer of water molecules are extra cohesive and create a skin-like surface. Okay, so you can go and slap the surface of the water. It feels like there's resistance there. Okay? And that's because this top layer, we're going to draw this top layer. So here's our water molecules. Draw these circles on your paper. They're all touching. Okay, that's that top layer. They're extra cohesive. So they are wanting to stick together more than normal on that top layer. And that's what causes that slap that you feel whenever you land on top of the water and it hurts. Okay? We are able to break that surface tension. Whenever you slap the water, your hand can go underneath the water, right? We're able to come up over that force of surface tension. We're heavy enough to break that surface tension. What's not heavy enough? What was our warm-up about? Bugs. Okay? So this, scientifically, is why bugs float on water.
Bugs can't go underwater.
Well, they can if you force them to. Some of them do. Some of them have that capability. But some of them, like mosquitoes, you can see and they're like standing on water, right? It looks like they're just floating there. They're not heavy enough to overcome that surface tension like we are. Okay? So your answers were correct in saying they're too light or things like that. But it also has to deal with not just the bug, but the water's surface tension. Okay? Bugs can't overcome that extra stickiness. So it looks like they're floating, but they're just not heavy enough to break that surface tension. Okay? That's the scientific reason why bugs seem to float on water.
Is that where density comes from?
Ish. Okay, I gotta scroll a little bit, so I'm about to erase all this. I hope you got it.
I used the note.
Alright, our next property of water is adhesive. What other property does that kind of sound like? Cohesive, but now we have a different beginning. We have a different prefix. We have AD. Okay? And I want you to think of that as the word add, like in math. So cohesive is water to water. Adhesive is water and something else. Okay, we're going to add something else. So water can also stick to other molecules. That's where the adhesive comes in. Water sticking to other molecules. So I always say water adding something else. Adhesion. So, this property lets us water our flowers. Okay? So, a little information about me. I went to college, obviously, and I was a science major. Okay? More specifically, biology. With biology, you get to learn a lot about what I thought at the time was random junk, like a semester-long plant course. Every day for an entire semester, I studied plants. It was a lot of fun. I learned a lot, but I didn't really understand it at the time. But now I'm thankful for it. Okay, so I learned this in my plant class, a little bit more in depth than what I'm going to go with you guys, but it made a lot of sense to me. Okay, so we're going to talk about adhesion and watering our flowers. I always thought that whenever I was watering any flowers that I had, okay, my dad had a lot of rose bushes growing up, so anytime I was watering the roses, I thought the petals of the roses were getting watered by absorbing the water that I put on them. Okay, I thought the petals at the top were just absorbing that water. Okay, I knew from like 4th grade that the roots obviously took up water from the ground, but I always wondered, what are those petals doing up there? Okay, and I thought that the water I sprayed on them was getting absorbed. That's actually not what happens. Okay, they don't have that capability to absorb those things. Leaves have a protective cover on them called a cuticle. They can't absorb that water. So how does that stuff get watered? Right? And it's because water is adhesive. So, here's my pretty flower. Okay, like I said, I took science classes, not art classes, so don't judge me. That's me watering my flower. Okay? Obviously, that water is going to go in the soil, and I know that my roots kind of soak up that water. All right? That part, we've been taught that forever, since we were little. Okay? But now, this adhesive property of water comes in. Okay? Kind of like Spider-Man can climb walls. Water is going to climb the walls of these roots all the way up to the wall of this stem, and that's how my petals and leaves get watered. Okay? They're not absorbing anything like I thought. They're actually using water's adhesive property. That water is going to climb up that side of that stem against gravity to water that top part of the flower. Okay? Whenever I learned that, it kind of blew my mind. I understand if you're not into it like I am, but that's fine. So water climbs against gravity to bring water to a plant due to its adhesion to the stem. Let me draw this. It's already on your paper. Okay, so you have 2 water droplets touching each other. What is that called? Water to water. Cohesion. Okay, this is that little picture in your notes. And then there's one over here. It has a water droplet and it's pointing to the side of the stem. So the water on the stem is called adhesion. Okay, so cohesion is water to water. Adhesion is water to something else like the stem of a flower. Okay, moving on to our next property of water, density. We've talked about density before as a physical property. We're going to talk more specifically about water. Okay, I want you to think about, you get this Dr. Pepper can and you're really looking forward to drinking it because Dr. Pepper tastes the best out of a can. Okay? But it's not cold, so you put it in the freezer. Alright? You forget about it. You go back to the freezer like 3 days later. What did that can do? It freaking exploded, and now you're grounded for like a month because your mom hates that you messed up her freezer because there's Dr. Pepper everywhere. Okay? Why did that can explode? Why didn't it just like stay frozen in the can? Caleb. What expanded? Specifically, the water inside of that soda expands when it freezes. Okay? That's what water does. It's different than other things. When other things freeze, it gets more dense and heavier. Okay? Like the solid version of mercury is way heavier than the liquid version of mercury. Okay? Ice does the opposite. The solid version is lighter. Ice is lighter than water. Okay? So, that's a density property of water. Water becomes less dense when it freezes. This causes ice to float on water. Okay? This is one of the only substances that does that, where the solid form is less dense than the liquid form. So we're going to talk about how does that help our fish? How does this property of water, where ice floats, help our fish in our ponds and lakes? Okay, so it is the blizzard of 2020. I'm surprised it hasn't happened yet, knowing this year it might. And now all of our lakes and our pools and everything have this ice layer on top. Go ahead and draw that ice layer for me. Okay, so we know that ice is going to float to the top, and it's going to keep all these little fishies in here. There's my fishies. Okay, so the fact that water does this actually helps our fish out. If water froze like everything else, so whenever it froze, it started at the bottom, and then as it froze, the ice just got higher and higher. what's going to happen to my poor fish? They're going to die. They're either going to sit there and freeze, or that water level is going to get so low that they run out of water and they end up suffocating on the top. Okay? Thank goodness that doesn't happen. Thank goodness water has this density property where the solid layer is less dense. That way, instead of the ice forming at the bottom and working itself up, it just stays at the top and my fish can still survive in that water underneath. Okay? So that helps out our aquatic life during the winter. Okay, we're almost done. Our seventh property of water is called heat capacity. You have experienced this as well. You just might not have known what it was called. I want you to draw this up arrow right here because water has a high heat capacity. Okay, a high heat capacity. And what that means is that it takes a lot of heat to make water hot. This helps regulate temperature ranges worldwide. It takes a lot of heat to make water hot. Okay, so you try to make some noodles, some spaghetti. It takes forever for that pot of water to boil, doesn't it? Okay, that's because water has a high heat capacity. It takes a bunch of heat to bring all of that water to the same temperature ready to boil. Okay, so let's look at this situation. We're going to draw a picture right here. Draw me some waves and sand. So here's our water. Here's our sand. Draw that for me, please. Okay, obviously we know that the sun is going to bring out some heat and heat up our environment for us. Okay, so we're on the beach. We get there, we put our sunscreen on, we're taking our flip-flops off, we step into that sand. What does that sand feel like on our feet?
Hot.
Really, really hot, like fire hot, like makes you slap your mama, right? So this sand is very hot. Where are you going to go to get relief from the sand? To the water because it's cooler, right? The water is usually cool. Why is that a thing? Why? I mean, it's not like the sun is just like not shining on the water. It's not like we're blocking the rays to the water. Why aren't the water and the sand the same temperature if they've been in the sun the same amount of time? Dylan.
The sand takes us, or absorbs more heat.
So the sand has a low heat capacity, which means it can't hold heat very well. So whenever it's in the direct sunlight, it gets hotter faster. This water is in that same direct sunlight, but it takes forever to get water hot. Like it takes forever to get water to boil, right? So that's why that water feels cooler, even though it's been in the sun the same amount of time, because it can hold heat really well. It has a high heat capacity. Okay? A couple of facts about water. What is the boiling temperature for water? At what temperature does water start boiling?
100 degrees Celsius
100 degrees Celsius.
and 212 degrees Fahrenheit.
212 degrees Fahrenheit. What about freezing point?
0 degrees Celsius, 32 degrees Fahrenheit.
Yes. Okay, so it's going to freeze at 32 degrees Fahrenheit. It'll freeze at 0 degrees Celsius. I've never understood why we don't use Celsius like everywhere, but Americans are like, no, we got to do our own thing. Everyone else can be smarter than us. It just makes sense that water would freeze at 0 and boil at 100 instead of 32 and 212. But whatever. Nobody asked me. I wasn't alive then. Anyways, before I get heated, last property of water, okay? It's the easiest one. I saved it for last. We know that water can exist in all three phases in nature. So what is water vapor in the air? Gas, liquid, or solid?
Gas.
Gas. What is water in a pond?
Liquid.
What is ice?
Solid.
Okay, that one's easy. We all know that. Okay? Now, use this note page to do that 5.1 assignment on Canvas. Okay, it's just 10 questions long. It is not going to take you long. Okay, 5.1 assignment. You can use these notes, keep these notes with you, all that fun stuff. Is everybody good with what they're supposed to do? Swag.